start. Hello there, how's it going, guys? This is 8.2, Law of Sines. And law of sines can be used for a few different situations. We're going to start with the situation of angle, angle, side, and angle, side, angle. Now, hopefully you're thinking, hey, that sounds familiar. Angle, angle, side, angle. Sounds like geometry. Yeah, kind of similar. This property, law of sines, this equation only works if you have a triangle where you know the angle, consecutive angle on a side, or two angles in the side in between them. Now, that means that we're not working with right triangles anymore. Previous section was solving right triangles. Here we're solving oblique triangles, meaning triangles that are not right. So the law of sines is as follows. The sine of angle A divided by side A equals the sine of angle B divided by side B, which equals the sine of angle C divided by side C. Now, in reality, when you're using this equation, you're either going to only have, sine A over A equals sine B over B, or sine B over B equals sine C over C, or sine A over A equals sine C over C. You're not going to have all three, but they're all equal to each other, so either combination works. Also, these are proportions, means you can flip them. So you could also, depending on what your variable is and what your unknown is, you might want to switch these. So you can also have A over sine A equals B over sine B equals C over sine C. Okay, the first example we're going to do is number 12 on page 527. We've been given this information. Angle B is 30 degrees, angle C is 125 degrees, and side B is 10. Notice the capital letters are for angles and lowercase is for the sides. Remember, this is not a right triangle anymore, so it's not angle C is always 90. It can be anything. So purposely set it up to draw our own triangle. Whenever I draw my triangles, I always have it looking the same, with something like this. Now, it might not be drawn to scale, right? Like it could end up being where, obviously the way I drew this triangle, none of these angles are bigger than 90. And this one's supposed to be 125, but whenever I draw my triangle, I just draw it like that. So deal with it, I guess. Angle A, angle B, and angle C. 125, 30, and side B. Opposite of angle B is 10. So once you plug in the given information, let me see, okay, I've got an angle, and then an angle and a side, or a side, angle, angle, right? Angle, angle, side is equal to side, angle, angle. Same thing. So this can be done with law of sines. I need to find side C, side A, and angle A. Well, angle A, hopefully you're thinking right now, geez, angle A, that's going to be easy. Just do 180 minus 125 minus 30. So let's see. 125 plus 30 is going to be 155. 180 minus 155 is going to be 25 degrees. We need a calculator here just a second. And not too smart, Mr. Pines didn't remember his calculator. So pause this for a second. Alright, back. So I want to find, in order to solve for one of these sides, A or C, okay, we're using law of sines. I have four pieces of information. I have sine of an angle divided by the side equals sine of an angle divided by the side. So there's four things. You have to have only one unknown. So I need three pieces of information, and I need what I call a pair. A pair meaning I need an angle and the opposite side. I need to know what they are. So I have to use B. So I have side at B and I have angle B. So I have to use this pair. And let's find side A first. Since A is the unknown, I want to have that in the numerator because if you put variables in the denominator, it creates an extra step. Right? So let's go A over sine of A, which is 25 degrees, equals, let's go B, which is 10, over sine of B, which is sine of 30. Well, that's going to be 1/2. I like that. A equals multiply, we get 10 times sine of 25 degrees divided by sine of 30 degrees. Now technically sine of 30 we can do without a calculator, but we need a calculator for this anyway. And you punch in your calculator, and you get A is equal to 8.45. Okay, so we have one more unknown to find, which is side C. Watch out here, very important. Do not use A and angle A to find side C, because A is rounded. Yeah, I put 8.45, but it's not exactly 8.45. I had to round. If you use a rounded answer to find your next variable, you'll get a bigger round off there. It's not good. So instead, I'm going to use that same known pair to find C. So let's go side C divided by the sine of C, which is 125, equals side B, which is 10 over sine of 30. 8 multiply, it's C equals 10 sine of 125 divided by sine of 30. Okay. Punch in a calculator. Make sure your calculator is in degree mode, right? You can be in degrees or radians. So you're in degree mode. And C, you will get 16.38. Here, our next example, number 20, we've got A equals 70 degrees, B equals 60 degrees, and side C equals 4. Well, again, I'm going to draw a triangle. And let's go A, B, C, doesn't matter. A is 70, B is 60, and C is 4, opposites. So this is angle, side angle. So anytime you get information about a triangle, you label the triangle and then you look and say, okay, I got an angle. Oh, angle, side angle. Anytime you have angle, side angle, or angle, angle, side, you know that's the law of sines. It's the only one you can use. So in order to use law of sines, I need a pair, meaning I need a side and its opposite angle to solve it. And I don't have that yet, but I can find the third angle because I now have two of the other angles. So 70, 60 is 130 plus 50 would be 180. So C is 50 degrees. So I have to use this pair to find either side B or side A. Let's find side A. A divided by sine of 70 degrees equals 4 over sine of 50 degrees. A equals 4 times sine of 70 divided by sine of 50. Remember, there's no canceling here. You don't do like sine divided by sine, it's no good. 70 divided by 50 doesn't become 7 over 5, right? You're not dividing here. Sine of 70 times 4, then divide by sine of 50. And you just do it on your calculator, you do it on Desmos. A, you get 4.91. Okay, let's find side B. Again, I don't want to use answer for A to find B because we'll get a round off pair. So use that same pair of C. Let's go side B divided by sine of 60 equals side C divided by sine of 50. B equals 4 sine 60 divided by sine of 50. We get B is 4.52. Alright, that's it. Solving oblique triangles for law of sines. Next video will be continuation. So, we went over angle, side angle, and angle, angle, side, angle, angle. You might be thinking, hey, there's some other ones I remember from geometry. Hopefully you remember some other ones. There was one here, you should remember that was bad, right? It's when you have, angle, side, and then side. What? Nope. not gonna write it, right? If you have side angle, right, that's not okay. It's called the ambiguous case. So next video, 8.2 continued, we'll go over what you do when you have side angle. And actually it's kind of funny, it says 8.2 continued, except actually that video was made a few years ago. So it's kind of like going back in time, or like this was the prequel. So I made that video and I had to go back in time to make the prequel. I don't know. Doesn't make sense. Anyway.